Welcome to Maths and Science Academy. Today we will be looking at trigonometry. Let's get into it.
If sine 40 degrees is equal to p, write each of the following in terms of p.
Question 5.1.1. We are given sine of 220. We have to write it in terms of p.
Using this trigonometry Cartesian plane and reduction formulas written in blue and also in green.
In grade 12, we're going to use the circled reduction formulas mostly. And remember, we are given sine of 220. And we know that 180 degrees plus 40 degrees is equal to 220 degrees. Therefore, sine 220 degrees will be rewritten as sine of 180 degrees plus 40 degrees.
And by the aid of the trigonometry Cartesian plane, we can see that 180 degrees plus theta lies on the third quadrant.
Hence, by using cast, on the third quadrant only tan is positive, therefore sine will be negative, giving us negative sine of 40 degrees from this reduction formula, which is equal to negative p, since we know that sine of 40 is equal p, as given on the statement.
Question 5.1.2. We are given cosine of 50 squared.
We know that 90 degrees minus 40 degrees is equal to 50 degrees.
Therefore, this can be rewritten as sine of 90 degrees minus 40 degrees.
I made a mistake. There is actually still cosine of 90 degrees minus 40 degrees, all squared.
From the trigonometry Cartesian plane, we can see that 90 degrees minus theta lies on the first quadrant, where all trigonometric ratios are positive.
And cos of 90 degrees minus theta is a cofunction identity.
Let's try and prove that this cofunction identity is true.
Consider a right-angled triangle with angles theta.
Let's try to find the third angle of this triangle using the sum of angles of a triangle theorem, given as 90 degrees plus theta plus the third angle, which we are going to label it to be angle x, will then be equal to 180 degrees. Sum of angles of a triangle equal 180 degrees.
Therefore, x equal to 180 degrees minus 90 degrees minus theta, not x. Make sure you fix to that, whereby everything was transposed to the right of the equal sign. Now simplify 180 degrees minus 90 degrees is equal to 90 degrees minus theta. It's actually 90 degrees minus theta. Make sure you fix to that. Now let's consider our complete right-angled triangle with a right-angled 90 degrees. Angle theta.
And then third angle, 90 degrees minus theta, not x. Make sure you fix that. We will then label the vertical line as our y, our horizontal line as our x, and the hypotenuse as r.
For cosine of 90 degrees minus x, which is equal to.
Using SOHCAHTOA, we know that cosine is equal to the adjacent sides over the hypotenuse, whereby y is the adjacent side of angle 90 degrees minus x, giving us y over the hypotenuse side, r.
And consider sine of theta. From SOHCAHTOA, sine is given as opposite over the hypotenuse side.
Therefore, sine of theta will then be equal to the opposite side of angle theta, as y over the hypotenuse side, r. Therefore, sine of theta is equal to y over r, as cosine of 90 degrees minus theta. Therefore, cosine of 90 degrees minus theta will then be equal to sine of theta, since they are both equal to y over r.
Hence, we prove that cosine of 90 degrees minus theta and sine of theta are cofunctions. Now considering cosine of 90 degrees minus 40, all squared, will result into its cofunction sine 40 degrees squared.
which is equal to p squared, since we know that sine of 40 degrees is equal to p, as given on the statement. Question 5.1.3. We are given cosine of negative 80 degrees. We know positive angle is measured anti-clockwise, while the negative angle is measured clockwise. And we are going to construct a vertical line that is illustrated in black, resulting into the formation of two triangles.
The upper right-angled triangle has a side labeled as positive y, since this side lies on the positive y-axis, and the other one will be labeled negative y, since it lies on the negative y-axis, and the hypotenuse of both triangles will be labeled r. The horizontal line lying on the positive side of the x-axis will then be labeled x.
From SOHCAHTOA, cosine is equal to the adjacent side of negative theta over the hypotenuse side, giving us cosine of negative theta equal to the adjacent side over the hypotenuse side. Hence, in this case, we can see that from negative theta, the adjacent side is x, and the hypotenuse side is labeled r. This implies that cosine of negative theta will then be equal positive x all over r, which is always positive. And considering cosine of positive theta is also equal to positive x all over r. Therefore, from this we can conclude that cosine of positive theta is then equal to cosine of negative theta. Cosine of negative 80 degrees is equal to cosine of positive 80 degrees. And this can also be rewritten as cosine of 2 times 40 degrees.
And by using the double angle rule, we know that cosine of to alpha is equal to 1 minus 2 sine squared alpha.
Therefore, cosine of 2 times 40 degrees can be rewritten as 1 minus 2 sine squared 40 degrees, which is equal to 1 minus 2 p squared.
You